Hey, Razz. So, Razz, I just gotta ask, what happened to the eye? Oh my, that had to hurt. So, Razz, today we're supposed to talk to the students about updrafts and downdrafts, right? So, updrafts and downdrafts happen. You remember the lab we looked at sunlight on the soil got warm, and the sunlight on water and snow got cold. And so that air got warm over the soil and got cold over the snow. And what we need to talk about now is how where you get the warm air, right, it goes up. And we get an updraft over the warm air. And over the cold air, we get a downdraft. Does that make sense? Yeah? So, okay, updrafts and downdrafts. Why? Oh, why? Why do we have updrafts and downdrafts? That's a good question, Razz. So, well, we have hot air and we have cold air, right? And hot air rises. Have you heard that before? Right? Hot air, like a hot air balloon, right? It flies because hot air rises. And if we think about that, that means cold air sinks, right? Right. So does that make sense? Hot air rises, right? That's a rule. Why? Oh, good question, Razz. Why does hot air rise? Well, let's think about it. Hot air is less dense than cold air. And so it's not really just rising, it's floating. Just the same way styrofoam floats on top of water, right? You got a boat or styrofoam or something like that, it floats on top of water, right? That makes sense? Well, that's what hot air is doing. It's less dense so that it floats, and cold air is more dense, so it sinks, right? Does that make sense? So, hot air floats and cold air sinks. Why? Good question, Razz. So why is hot air less dense than cold air? Well, that has to do with the spacing of the molecules. The particles in hot air are farther apart. So they're spread out farther, and so they are more spread out, less dense, right? Does that make sense? Right? Because the particles are farther apart, they have a bigger volume for the same mass, right? Cold air, the particles are really close together, so they are more dense, and because they have more mass in a given space. Does that make sense? Okay. Good. Hey, Razz, let me show you this experiment. I'll take this Gatorade bottle with a glove on top of it, and I put it in some hot water. And that warms the air inside, and that makes the air molecules inside move faster. And then because they're moving faster, they spread apart from each other. Now, if I took the same bottle and let it cool back down, what do you imagine happens?
The glove will shrink.
Yeah, that's right. The molecules slow down, so they get closer together, and eventually the glove falls back down because they're not spread out as far. Now, if we cool the air that's inside the Gatorade bottle, the glove really shrinks. This is because the molecules are moving slower, they get closer together, they're more dense, and so they take up less space.
Razz, it's time for us to learn about the words of the day. Oh my gosh, is that your eye? We have 3 new words of the day. Would you like to learn those words, Razz? Great. Well, those 3 words are air mass, updraft, and downdraft. Let's learn what those words mean.
Razz.
An air mass is a volume of air that has a specific temperature and humidity. So for example, we have an air mass right there, and it has a temperature of 70 degrees Fahrenheit and 63% humidity.
Razz.
An updraft is when an air mass is warmer than the air around it. So it will move up because it is less dense. So for example, if the temperature was 60 degrees Fahrenheit, and then we had our air mass that's 70 degrees, it's warmer than the surrounding air, so it's going to move up.
Razz.
A downdraft is when an air mass is colder than the air around it, and it will move down because it is more dense. Okay, so for instance, if the temperature was 80 degrees Fahrenheit, that means that that air mass that's 70 degrees Fahrenheit is surrounded by warmer air. So it's going to start moving down. And Raz, that's our words of the day. Do you have any questions?
Hi, can I help you, young man?
Excuse me. Elmo wants to know if he's on Sesame Street.
No, you're here on Highland Avenue.
Oh.
Razz.